we're going to start to look at functions in linear equations. So these will all be the real simple or basic ones. For something to be a linear equation means that its graph will form a straight line, so there's no curves or bends or changes in it. But if we look at the first section, talking about functions, does anybody know what a function is? Any ideas? You guys have heard it, the word before, though, right? Yeah, right. Okay. So one of the ways that functions are notated, f of x is equal to, this is called a function notation. Okay. And so what this means is, so let's say we take some linear form, just a real basic linear form here. And what a function means is that for any given inputs, and so each distinct input, whatever you happen to plug in for x in this case, will always yield one specific output. And now, here's kind of where the confusion on functions sometimes comes. Okay, so notice I use the words distinct and then specific. Okay, so distinct means that for any different number that you plug in for x, okay, you're going to get one value out of it, and that value is always going to be the same. It'll never change. So if I plug in, let's say, the number 7 here, no matter how many different times I plug in the number 7, you're always going to get the same output. Now, that doesn't mean that this output can't be the same for two different numbers that are plugged in. And because if I take something like this, right here, okay, this is still a function. Okay, if I plug in, let's say, the number 5. Okay, so if I plug in the number 5 for x, what is my output? 6, right? Always going to be 6. No matter how many different times I plug in 5 to this function, you're always going to get 6. That's what defines it as a function. Any distinct input yields one specific output. It's not like you'll plug in a 5 and then one time you might get a -7. Another time you might get a 6. Okay? Now, that doesn't mean that, let's say I plug in a -5 here. If I plugged in a -5, what would my output still be? It's still 6. So the outputs can be the same. And so you can have the same outputs for different inputs, but you can't have the same input with different outputs. Right, Lauren, did you have a question? So what distinct mean is for any different x value, it's going to yield a specific output that it's specific only to this number. What I'm showing here is it is possible for the output to be repeated so that it's not a distinct number. If this had been yields one distinct output, then that means that no other value that you plug in could give you a 6. But that's not the case. Okay, for a function, when you plug something in, it's the inputs have to be unique. Okay, so for any given input, it always yields the same output. So it would be like, I mean, even something as simple as like a gumball machine. And so if you had a gumball machine at your favorite restaurant and you plugged in a quarter, right, and you got a gumball, like your expectation is that that's a function relationship. Every time you plug in a quarter, you're going to get a gumball. What if you plug in a quarter and then you get one of those crazy bracelets that are in the shape of little creatures or animals or whatever? Okay, there you go. Okay, so then if that's the case, you plug in the same input but you get something different out, then that would not be considered a function. So anything can be described as a function. I mean, we're going to use algebra and equations and stuff to do it. Often what you're going to see is some different ways that functions are notated. And one of the ways that you're going to see in this is kind of an input and output chart. Okay? And so if you had something that gave you a set of inputs and gave you a corresponding set of outputs, okay, when you're looking at these, the inputs are also called domains. And the set of numbers that can be your outputs are called what? Do you guys remember that? Domain and range. Good. Okay. So it goes alphabetical, just like x, y. X is your input, so that's domain. Y is your output, and that's range. So it's alphabetical for all of those if you ever are wondering or mistaken or aren't sure. So if you look at this, if I have set up something like this, where I show this relationship, okay, as it sits right here, this is a function, right? Any distinct input yields one and only one output, correct? No matter what. If you pick -3, you're always going to get an output of 4. If you input -1, you always get an output of 1. If you input 2, you always get an output of 0. So this would describe a function. Now, what if I did something like this? Would this describe a function? For any input, it's always going to end up with the same output. Yeah, it's still a function, right? -3 corresponds to 4. -1 yields a 1. 2 yields a 1. It doesn't matter that the outputs aren't distinct. They just have to be specific. They have to be the same and consistent all the time. Okay, now, what if I did something like this? Now is this a function? Now it's no longer a function because an input of -1 doesn't yield one specific output. It might yield a 0 and it might yield a 1. So in this particular case, you would not have a function. And is everybody able to see that kind of distinction there? All right, if you take a look at, let's take another chart just like this. I want you to tell me if this is a function. Okay, would that be a function? And the answer is yes, because again, there's only one branch from each input. Okay, what about if I added this line? Now is that a function? Now it's no longer a function. Okay. Right, as far as let's look at a table of values. So you might see functions represented with the input-output. And when you look at a table of values, so let's say a set of x and y coordinates, that correspond to a set of values along the y-axis. Okay. Would this be a function? Would this set of values represent a function? Yeah, for any given x value, x's are your inputs and y's are your outputs, which means x's are your domain and y's are your range. Okay. For any given input, there's one and only one output. So this would represent a function. Okay. What if I gave you a set that looked like this? Would this be considered a function? Now it's not, because you have a repeated input, right? 2. And each time it repeats, do you get the same output? No, so this would not be a function.